All right, pre-calculus, welcome back to learning. We're just going to spend this week reviewing, and so we basically did section 5.4. Gosh, what was it? 2 weeks ago now, for our 1 week of remote learning. And so we're going to start by having a couple of slides of reviewing the fundamental properties, and then we're going to end with reviewing the properties of logarithm, just so that you guys will be able to do this week's assignment or task easily. So again, looking at solving exponential equations, we want to isolate the exponential term first, then rewrite it as a log equation, and then use the calculator to find the value. Or you could leave it in the exact form. So notice this says write answers in exact form and approximate form. So we'll talk a little bit about that. So if we want to isolate just the exponential part, we're going to add 29 to both sides. That leaves just 10 to the x on the left, and 29 plus 51 is 80. Now, if we want to get rid of the base 10, remember how we undo exponents is we take the logs of them. So we're just going to take the log of both sides. So what we really have here is log base 10 of x equals log 80. Remember, these undo each other. So we're given x equals log 80. This is my exact answer. And then if you want to find the approximate, you're gonna use your calculator. You have your log button right there, log 80, and we get about 1.903. So my approximate is about 1.903. All right, so take a moment, maybe pause this video and try the next one on your own. After you get done doing it, you can go ahead and unpause and come back and check and see if you did this one right. So knowing my steps are, I need to isolate the exponent. You should have added 5 first to both sides, giving you 3e to the x plus 1 equals 12. I still haven't isolated the exponential part, so I'm going to divide both sides by 3. That gives me e to the x plus 1 equals 4. And now I need to take the log of the same base, and since this is the natural number, I'm going to take the natural log of both sides. So let me move over here. When I do that, I get the natural log of e to the x plus 1 equals the natural log of 4. These undo each other. So we're given x plus 1 equals natural log of 4. And then to solve for x, I just want to subtract 1 from both sides, and this is my exact answer. If I put that in my calculator, if I take the natural log of 4 and then minus 1, so put it in like that, then I get my approximate answer is 0.386. All right. So we solved exponential equations on our first week of remote learning, but we also solved logarithmic equations. So if we want to do the same thing, instead of isolating the exponential term, we're going to isolate the log term, and then we're going to undo using exponents instead of logs. So here we subtract 1 from both sides. We get 2 log of 7x equals 3. Now we need to get rid of that 2, so we're going to divide both sides by 2. I get log of 7x equals 3/2. Then to undo a log with the understood base 10, I'm going to have to take it to from the power of 10 on both sides. So these undo each other, and I get 7x equals 10 to the 3/2 power. I would then want to divide by 7. And I really want you guys to try this at home on your calculators to make sure that you're doing the right order of operations when you want to come up with the approximate answer. So I would do 10, use my caret there to go to the 3/2 power. And then I would arrow over, and then that is all divided by 7. So when I do that, I get x is approximately 4.518. Right? We got one more. So again, just like on the previous slide, if you guys would pause your video and try this one, it's really important that you understand it. It's not important that you're just watching me and can understand when I do it. So pause the video. When you come back, then you can check and make sure you did it right. All right, so you should have added 5 to both sides first. I go over here, which gives you -4 times the natural log of x plus 1 equals 12. Then I would want to divide both sides by -4, which then isolates just the logarithm part. We know that the base of natural log is e, so we're going to have to exponentiate both sides by e. So these cancel out, leaving me with just x plus 1 equals e to the -3rd power. Then I would need to subtract 1 from both sides, giving me my exact answer of e to the -3 minus 1. If I want to put that in my calculator, I'm going to have e is right here above the natural log. So you have to use the second button. So you get e, then I'm going to put in, make sure you use the negative, or otherwise you'll get an error. -3, then scroll over, -1. That's the correct format. And so we see our answer is about -0.95. So our approximate answer is about -0.95. All right. We have one last slide in our review today. And it is using the logarithmic properties. You can go back to, I believe it was Thursday's lesson, where we used the logarithmic properties. Actually, I think it was Wednesday's lesson before we went on this pause. And it was the product property, the quotient property, and the power property. So we want to write these or expand these terms. And so we know first we're going to look at this x squared times z. We know that multiplication is addition with log properties. So my first step might be to write this as log of x squared plus log of z. So that shows the multiplication between x squared and z. And then I'm not fully simplified because that 2 is an exponent, and that was the power property. Knowing that all exponents, I can write them out front. So I would have 2 log of x plus log of z. So this is writing it in expanded form. And we're going to try it one more time with this other example, and then I'm going to give a handwritten example of writing it in expanded form, and then we want to write it in single term. So first thing we need to recognize is that this whole thing, this square root, remember the square root of x is the same as x to the 1/2. So we can actually write this as natural log of x divided by x plus 5, all to the 1/2 power. Now we'd want to use the power property, so that comes out front. So we're going to have the 1/2 times the natural log of x divided by x plus 5. Now division here, that was subtraction, but this whole thing is multiplied by 1/2, so be careful. You need to put your 1/2 out here, and then we would have in parentheses natural log of x minus the natural log of x plus 5. And that is writing it in fully expanded form. You could also go ahead and distribute the 1/2 if you liked. All right, one last example. This is your only video for the week. It's a little longer than I like to do because they take a while to upload. But let's say we had log of x plus log, or 3 log y, that's a minus log z. So we had it in expanded form, and I said now write this as a single term. So one thing you should recognize is that this 3 only goes to the y. So if it's out front here, it means it was really an exponent. So maybe if you don't want to do it all in one step, your first step might be to write it like this, where you have log of x plus log y cubed minus log z. So we know that addition is really the product property. So that means these two are multiplied together. So we have log of xy cubed minus log z. And then because multiplication and division, subtraction represents division, are equal, you just go in order from then. So notice how I multiplied these two first. Now I'm going to do division, where my final answer should have been log of xy cubed divided by z, all in one term. It wouldn't be divided by log z, it would just be xy cubed over z. All right, if you have any questions, we will have time during my office hours, so you can email me if you for sure want an office hour. We will review this in 2 weeks when I talk to you next after spring break.